Welcome back to the another session of our data structure journey. Today we are going to learn how it is a circular linked list. So what is a circular link? Circular linked list is a data structure where the last node connects to the back to the first node, forming a loop. For example, this is our linked list. What is a linked list? List of elements connected together through the link. So for example, this is a linked list. So here what happened? Information store we store. Till now we are covered single linked list, double linked list, and here this is the start node. This is the last node. For example, this is a single linked list. So here this is the last node. So this is we call as the single linked list. A circular linked list is a data structure where the last node means this node connects back to the first node. So previously what happened? It points to the null, but right now what happened? It connects to the first node, making a loop. So that this is called as the circular linked list. This structure allow continuous traverse without ending interrupt. So here we can able to traverse each and every node without any interrupts. We traverse a circular linked list until we reach the same node. For example, I start from this node. If we start from this node, second node, we can traverse until we are not reached the same node. Third node, I started from this node. Then we can make the traversing until we are not reached the same node. This is the case. Circular linked list has no begin, no end. So there is no begin, there is no end. We can start from any node and we reach in the same node. So there is no null value present in the next part of the node. Each and every node store the address of next node. So there is no null. In previous video, we are already compared single linked list, double linked list. There what happened? Last node. In case of single linked list, last node points to the null. In case of double linked list, what happened? The last node next point to the null and back node of the start node points to the null. So there is a chances of null value. But in case of circular list, there is no chances of null value. Then what are the different types of circular linked list? There are two types of circular linked list. First one is the circular single linked list, circular double linked list. So let us first complete the circular linked list single. So then we have to know what is a circular linked list operation. So there are various operation is present for insertion. Insertion means we are adding a value into the single linked list. So it can be insert at the begin of the circular linked list, insertion at end of the circular linked list, or any position. So any position we can insert. Similarly for deletion, we can delete the first position or we can delete the last position or any specific position. Traversing means to visit each and every node present inside the circular linked list. We called as the traversing of the circular linked list. Then searching. We are going to search any element present inside the linked list or not in the case of the circular. So this is the basic operation. There are so many operations we can perform in the circular linked list, but these are the basic operation. So next we have to understand what is a inserting and a node in a circular linked list. So here we have to know what is the logic behind for inserting an element into the circular list. So first what happened whenever you go for circular list, it is a dynamic memory allocation. So case one, whether a memory allocation is done or not. If the memory allocation is not done means we cannot able to insert. Second case, whenever we go for insert means list is empty or not. List is empty. List is empty means what? There is no element. So at that time what happens? Start is a pointer and last is a pointer which points to the null value. Initialization. So details before going to the circular linked list implementation or things. So first we have to know the single linked list. So all the details of the single linked list operation I have already make a video, so you can go to visit that. This is a prerequisite. If you go for circular single linked list, prerequisite you should understand the single linked list. Then only you can go for the circular linked list. So for complete the single linked list, so you have to just visit my previous video. In the description section also I make it. Otherwise if you know it, then it's good and well, we can go ahead. So List is empty. So if the list is empty, then what happens? Start and last two pointer points to the null value. Then what happened? We have to create a memory allocation per node. So in this case, what happened? We have to declare the structure node is the we are implementing the C language. For that, we have to declare the integer info, then structure node star next. Means two pointer we have to declare. One is the information, so two elements, one is information, second one is the next is a pointer. So a node has two component. First component is used to store the information part, second node is used to store the address of next node. Because it is a single linked list, only one direction link is possible. So we create a node. So for example, I make the node as a new node and memory address is 100. So malloc function successfully, we create a node, store the information. For example, I want to store the 5 value. Okay. So now what happened? This is a new node. So new node we have to make as a start, we have to make the 100. Last also we have to make the 100. So start point to this one right now, last point to this one. So this is the case of single linked list and we have to store the null. But circular linked list means the last node points to the first node. So now here what we have to store 100. If we store the 100 value, then what happened? Connection established to the. So this is a single node in our circular linked list. So whenever you go for insert into a begin of the linked list, so at that time what happened? If the list is empty, then this is the operation we have to perform. So second case is the list is not empty, means the element is already present inside the linked list. Let us take an example. This is the linked list. Element is already present. So list of element is present. Each node has two part. For example, this is 100, this is 200 address, this node 300 address, this node is the 400 address. So this is the start node. Now points to this one. This is the last node, point to this one, means last store which value 400. This store the 100 address. Now this store the 200 address, this store the 300 address. This store the 400 address. Now it is a circular linked list, means it store the 400 address. So it points back to the this. Information is stored 10, 20, 30, 40. So this is the single linked list is a surplus linked list is already present. Now what is our operation? Operation is to insert into the first begin of the means here we have to insert. So what are the steps? First step we have to go for memory allocation. If the memory allocation is done, for example, memory allocation is done and memory is 500. For example, now we have what are the operation we have to make? We have to make that here we have to store the information. For example, 50 information we store. Now if we want to insert into the first position, means this node next should be point to this one. So what information we have to store? We have to store the 100. If I store 100, means the connection established here. Then what happened? This is the last node. This last node. Now what we have to make? We have to make this last node should be connect to this one. So here what information I have to store? Right now if I store the 500, then only the node can be connected to this one. So for example, I store the value of 500 here. If I store the 500, then what happened? This connection is gone. Then new connection, that is this connection is done. Then what we have to make? We have to make this node as a start node. So what we have to make? We have to store the value of start equal to 200. What is this node value? 500. So we have to store the value that is 500. So then we have to store the value of start equal to 500. If we make the start equal to 500, then what happened? This node connect to this one. So our insertion in the first position is completed or not? So insertion is complete. So this is the way we have to insert at the first position of a circular linked list. So let us understand the algorithm for insert at first position of a circular linked list. So first we have to allocate the memory for the new value we want to insert into our circular linked list. Then we have to check whether memory allocation is done or not. Means memory is available inside our memory or not. If the memory is not available, mean then what happened? We have to print the error message, or insertion not possible, and we have to exit. Otherwise, we have to store the address of newly created node at a new pointer. So whatever node is created, we have to make as a new node pointer. Then the new node we have to insert into the first position. First position, again, there are two cases, whether list is empty or not. If the list is empty, then make the new node as start node as well as the last node. Then store the value inside the data position and make the next pointer of last node to the start node. Then our insertion complete. If the list have more nodes, means not empty, then new node next pointer point to the start node, last node next pointer point to the newly created node, and make the start as a new node. After that, our insertion is completed. Algorithm we have to follow. So first we have to create a new file, source file. For example, I have to file save, then we have to write down the code. So here we put output, then we have to include malloc.h. Reason is that we are using the malloc function to insert the to allocate the memory for the insert any value. So first we have to declare the structure declaration. Here I use the type def because we don't have to write down each and every time the structure keyword. That's why I make the type node. So node has two parts. First one is the integer info we want to store. Second one is a pointer points to the next node. So this is our node declaration is over. Once the node declaration is over, then what happened? We have to make 2 points. That is start. We make the start as a null value. Then we have to make the last. Actually, we don't require last value that much. Only in circular linked list what happens? Start node points to the last node. So there is only one pointer is sufficient. But still I prefer to use the last node because whenever we have to do any operation with the last node, unnecessary we don't have to traverse. That is the reason I have used the last node. Otherwise, no need for the last node. Last node pointer. So we declare this one. Now we have to write down the function. So function here for simplicity, I make the function does not return any value. Also does not take any parameter. So here, this is the function declaration. Once we write down this one, then so here we have to go for allocate the memory for the node to insert the value. So first we have to allocate the memory. So let's take that pointer, new node pointer. New node is the pointer. We store the address of newly created node. So we have to use the malloc function. Malloc, then size of, we don't know how much memory we want to allocate. That's why we have to use the size of operator to allocate the memory. Once the memory allocation, whatever value, if successfully it returns the starting address, unsuccessfully it returns the value of null. So we have to check if new node equal to null means memory allocation is not possible. It is very rare cases, but still we have to go for it. Printf insertion not possible. Else memory allocation is done. Once memory allocation is done, then what happened? We have to ask the end user to enter the value, which value you want to store. So that's why we have to use the printf. Then scanf. You have to store in a variable n. So we have to declare also n is a integer data type. So we scan it, then we have to store the value, new node. This is the info part. Info equal to n, we store value. Then we have to store in a proper location. Proper location means we have to insert the first position, but before that we have to check whether the list is empty or not. If the list is empty, then we have to make the new node as a last one. Otherwise, remaining procedure is the same. So we have to check that is the new node equal to, no, not new node. We have to check the, for that we have to check list is empty or not. For that we have to make the start equal to null. If start equal to null means list is empty. So if list is empty, so list is the empty. Then if the list is empty, then what we have to do? We have to make the start equal to last equal to new node. Then we have to make the last next equal to new node. So this steps for common for all the things, all the procedure. That is the whether the list is empty or not. Same thing. That is the list have nodes. Then what are the things we have to do? Then you have to make the new node next as a start node. We have to make the connection to the start node. Then last next. Last next equal to new node. Then you have to make the start equal to new node. Because insert first position we have to do. So once the both the if that is the list is empty or list have elements or all the things is over, then we have to write down printf successful. Insertion successful. You can observe that is the last next equal to new node, last next usually is the common. So you can make here a last info and then the same line that the last next equal to, but only problem is occurs that if you make this line here common, then what happened? Initialization, it is null. That's why we put the last next equal to null in both the cases. If you may think that it is a common and you put here, then what happened? You thought that whatever you did correct, but whenever you go for run the program at that time, you are not getting the correct result. Logically, compilation no error, but logically, logically, if I put this line last next equal to none means whenever the list is last is null, null next point the value of new node. After that, what happened? Insertion is completed. First node is okay. Next node, you will get the error message. So now we have to understand how to traverse the circular linked list as well as how to print the value. So first step is that we have to check whether the list is empty or not. If the list is empty means we cannot print any value. We have to just print that list is empty and we have to exit. Otherwise, we have to store the start value in a temporary pointer, print the information part, and we have to move to the next. And we have to continue the loop until we are not reached the end of the loop. So, for example, this is our linked list is given. Circular list little bit different from the general list whenever you go to print value because last node is always points to the first node. We cannot make the, we have to traverse until we are not reached the value null. So if right now this is start as well as we store the value 10. Now we have to print this value. After that, we have to traverse. So here what happened? For example, 5, 10, 20, 30 value is present. So first we have to print the info part. To how much? If I write down, that is this is the temp and we have to perform. So here what happened? Generally, we have to go for do while. So first we have to print the value. Then we have to make the temp equal to temp next. Then we have to make that is while temp is not equal to which value? Start or temp value. Reason is the start value. If you go for while loop, you print that is the start equal to next equal to null, then what happen? It will go to infinity loop. There is a chances of infinity loop. That's why we have to make the do while cases. Then only we can able to print the value. This is the only difference in case of single linked list, double linked list. Whenever you go for circular linked list, whether it is a single linked list or whether it is a double linked list, we have to print by help of the do while statement. We cannot go with the while. So now this is our display function. We are converted our algorithm to the display function. Here, if start equal to null means we have to print the list is empty. Then we have to store stem and we have to make the start. Then printf, we have to print the information and we have to terminate while not equal to start. Then we have to write down the main function. Main function, we are make a menu drive program. There are two cases right now. Insert into the first. How to write down the menu drive program? From starting to ending, I have mentioned in my previous program, that is the whenever we started the double linked list starting PDF, we are already completed all the details how to write a menu drive program. You can refer this one. Otherwise, you just go through the number of lines. It will be easy because I cannot do the same program multiple time in each and every video. It is unnecessary. Our time is consumption is more. So this is the case one for insert at begin. Case two is for the display exit. Only we are in this video we create a double linked list as well as we display the linked list. So create with inserting the element in the first position. So this is the case we are mentioning. So this is our menu drive program. So once we run this program, let us compile and run this program. So it is one for insertion. For example, I insert value is 11, insertion successful. Then again, I want to insert 22, then 33, then 44. Four element we are inserted, but it is inserted in the first position. Means before 11, 22 is inserted. Before 22, 33 is inserted. Before 33, 44 is inserted. If we print, the output will be displayed 44, 33, 22, 11. Let us go to for display. Display is 2. So 44, 33, 22, 11. So this is start and this is the last. So this is a simple program how to create a circular linked list and how to display. Creation means inserting data. Inserting data is insert into the first position. In this case, we are performing the operation. So this is our complete program. This is display function. This is the main menu program. Hope you are able to understand the concept of the circular single linked list as well as the implementation of the circular linked list. Thanks for watching the video. Please subscribe the channel, like the channel, as well as share the channel more.